Wait, my chat doesn't pop up anymore. Wait. Oh, it does work. It's just really delayed. That's crazy. Okay. At least it works. Okay. Prefix. So if we want to calculate the next cost to go from A to B versus A, no, no, A, no, the transformation cost, the index that you're currently on. Wait, what? Wait, what do you think happened? So I could kind of figure out where A to B, and it should cost 100. So what should my B, D, E, F? Hey man, grind again every day, man, every day. I solved this problem, but it was like terribly inefficient. If you see, like I'm cooked. I did a basically like did a for loop, but you're supposed to use prefix sum, so I'm trying to figure out how to optimize it and use prefix sum. I mean, it's 3361 if you are interested in the problem, but I'm drawing it out here. So I'm thinking, like, let's say we want to go from A to B, that would cost a total of 100 because A is at index 0 in alphabet, right? But how can we like store that somewhere, like pre-compute that? Let's say we have an array called. Thanks, man. I appreciate it. Next from A. So I feel like we should make this problem a lot simpler. It's just too much. One, two, three, four, five. I'm not sure if you left yet, but are you in school? Are you studying anything currently? One, two, three, four, five. A B C D. A B C D E. Okay, nice. Would it have a prefix sum array? Yeah, I'm in school. I'm interested in tech. Oh, nice, nice. Well, if you ever study it, man, pull up. I'm gonna start my college. Oh, you're in high school. I see. I see. Nice. What languages are you interested in learning, or what part of tech do you want to go into? It's pretty big. Let me turn on my light. I feel like that will encourage people to join the stream. Got to be professional. There we go. So from A to B costs 1. So that's what we're doing. Yeah, that would cost 1. From A to C. I think it should start off with 0. So A to A is 0 because you're already there. A to B is 1. Then going from A to C would cost 3. CS, I've always been interested in it, but till now I've studied Python properly. Oh, Python's good. They're probably gonna make you learn like C++ in college. Okay, wait. So let me get back to work. Wait, so A to D is how much? It should be 1. Wait, what? No, this is so this represents A to A. A to B costs 1. So it's everything behind the current index. A to C should cost 3. A to D should cost everything here, so that'll be 6. Right? Yeah. And then A to E finally would cost everything back here. So this would be 3 plus 3 is 6. So it'd be 10. So this is the cost to go from A to X, where X is any letter from A to E, right? And I think so. If we looked at this and said we want to go from position A to D, all we have to do is check our next array, look at index D, where it says 0, 1, 2, 3, 0, 1, 2, 3, and realize it's 6. But what if we want to go backwards? What if we want to go to A to B, but backwards? So we went A and then wrap around, start to E, D, C, and see how much that would cost. Okay. How would prev work? Prev. How would prev work? So to go to A is obviously 0. To go to A to E would cost 1. How are we calculating that though? I guess we're like going from the back of the array. So this represents A, E, D, C, and then B. So if I go to A is 1, to go to A to E is... No, to get A to A is 0, to go to A to E is 1, to go to A to D is 6. And to go from A to C would cost 10. And to go from A to B would cost 13. Is this wrong? So it'd be from A to B would cost 1, 6, 10, 13. Something seems off here. How does it cost more money to go backwards than forwards? Okay. So with this information, what can we do? If we had a transformation that is like A to D, what do we do? I say, well, A to D is 6. A to D is equal to 6 for the next. And then for previous, you check A to D. But you wouldn't be able to check. Oh, you would be. Why is this like written so? I'm pretty sure this should be in order. It should like work backwards. So it'd be like from going A to A and then going from A to B, but backwards. So that means you would go 1, 6, 10, 13. It would cost 13 to go to A to B, right? And then how much does it cost to go from A to C backwards? It would be 1, 6, 10. Yeah. How much does it cost to go to A to D backwards? 1, maybe 6. And finally, A to E backwards would just be 1. Nice. I think that makes more sense. So now in our A to D traversal with previous, we see that A to D costs, it still costs 6. They're actually equal. Bad example. Let's try something else. Let's do A to E. So A to E costs, in our next array, it costs 10. And A to E going backwards would cost 1. So we see that 1 is better, so we take that. But now, how do we do like intermediate? This all starts at A. So let's say we want to go from B to C. How do we check that? B to C. B to C. And it stands for forward. I think we go to B. So that's the 1 here. I think we just subtract it, right? From B to C going forward would cost 2. How do we get 2 from this? How can we derive 2? Well, I think you can just do the letter you want to go to in the next array, which is 3. The letter you're at, which is B, is 1, and then you get 2. I think that's the formula. And then we want to go to backwards. Let's say we wanted to go from B to C, but backwards. We see that to get from the letter we want to go to, which is C, costs 10 minus where we're starting from, which is B, which is 13. I mean, it should cost. No. Something's not right here. That'd be -3. We're trying to go from B all the way to C, but backwards. Would it actually cost 3? I feel like no. How much does it cost to get from B to C? 1. It would cost 10. Because it would take. Wait, no. B to C? No. To get from B to C, you would have to go B to A, which is 2. A to E, which is 1. So it would be all of these numbers plus all these numbers. So it would be 12. So the answer is 12. So how do we get to 12 using this prefix sum? I have no clue. So we know to go backwards from A to B costs 13. To go backwards from A to C. To go backwards from A to C costs 10, right? That's A to C. It costs 10. But what about going from B to C? Fifth. Damn, I'm kind of stuck. From A to C costs 10. So about B to C. B to C is 12. From A all the way around to C is 10. What about B to C? And you started. Oh, is that it? Is that it? So going from, you go A to C, and then you add the prefix of A to B. This kind of makes sense. So we figure to go previous, we have to figure out what's the price to go backwards from A to whatever character. And then we also have to add all the traversals going forwards from A to whatever B is, whatever. Does this work for other things? Okay, let's try one final example before we start implementing. So we want to go from C to D. So C to D. C to D forward, all we literally look at is look at our next array from A to C costs how much? 3. From A to D costs how much? 6. Let's just get the absolute value, so 3. Is that how much it costs to go to C to D? Yeah, so we just get the absolute value of the two indices, right? That makes sense. And then same thing for previous. If you want to go from C to D, but all the way around, you have to look at what's A. What's A to the letter you want to go to? Backwards would be 10. And then you want to add the forward traversal because you're going backwards, so it covers all these letters, but you have to also cover the letters from where your starting point is. In this case, C. You see that C is 3, so it'd be 13. Let's see, does this check out? Does that check out? So to go from C to D, this would cost 3. This would cost 5. This would cost 6. Ooh, that does not work. 5, 6 plus 5 is 11. All right, maybe, how am I figuring this out? C to D. Backwards. I don't know, man. That can't be the answer. Forward makes so much more sense, but like, why is it so hard to figure out the backwards? A to I'm pretty sure. So from A, we're trying to go from C to D. So if we look at what's we look at our previous and you say, well, what's A to D? A to D. Oh shit! I think I fucked it up. It's 6. A to D is 6, right? And we also have to add, because this is covering from here to, make some new colors. So this is covering from this blue to this blue, but we're trying to go from C to D. So that means we have to cover these two transformations too. So can't we just look into our array and say, hey, how much does it cost to get from C to B? I don't know. Plus 5 is 11? Damn it. Because it would cost 3, 5, 6, 11. So the answer is 11. How do we derive that though? I know that from A to the destination is 6 cost. But we need to account for these two letters here. What plus 6 is 11? 5. Damn it. Hmm, 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 hmm. So 8 is. No, because you. God, no, you can't. I bet. Good. So the formula would be. So the formula to go forward would be The difference between next at I and next but each index holds. I'm having trouble figuring out the formula. It'd be like the cost to go to I plus one. Yeah. Plus, oh, wait, what? Wait, so if I wanted to go from E to A, which would cost 5, I'm pretty sure I could just go. What's the price to go from A to E, which is 10. Yeah, I don't know. So from A to B costs 1. C to D costs C to D. That's where I messed up. Damn. Okay, what? So next cost would be from A to B, from A to C, from A to D, from A to E, and from A to E, and then from E to A. That's where I got confused because I thought, yeah, from E to A. Oh, wait, what? To go backwards from A to E would be 6. How the fuck do we get 6? Killing me here. So from A to E somehow cost 6. Wait, where are the here, But you didn't even give me. I don't really like how this how this works. From A to B should cost 0 though. Oh. I'm retarded. What's wrong with me? Forward prefix sum? Oh my god, this is exactly what I did. Actually got it right. Mine had 1, 2, 3, 4, 5. Yeah, this is actually what we got. So next cost is 1, 0, 1, 3. Wait, what? 1 A B C D E F. So it has an extra letter. Mine ended at 10. Mine ended at 10. But it's supposed to end at 15 because from going to A to E is 10. And then going back again? I don't know how that helped us. Oh, so that's showing how to get from A to A forward, I guess. The previous one, it makes even less sense. From A to A clause 0. Great question. This is a subtle, very important prefix sum detail. And your intuition A to A is not wrong to the conventions. That's what I had. E to A. Oh, X position 5. So from B to D, A, B, C, D. Wait, why are we doing 5? That doesn't even make sense. D to B. 15 minus 6. Yo, you're fucking killing me with this logic. Yeah, I don't know, man. Taking my break though. That was whack as hell. Wacky tobacco, man. No more bishops on the board, I guess. I'm not sure what was the whole point behind that one. Blockade pawn. Sounds like a good idea. 20 seconds. Oh, brother. Time. That's crazy. Yo, he's making me feel like this is the same guy, bro. He plays the same. What the hell? Bishop G5 again? It has to be the same guy. Did I offer a rematch to this guy? I don't know. That guy is pretty annoying. What's up with this guy? Bishop C1. That he's like that type of guy. He's that type of guy. I can see it in his bones. No, he's not that type of guy. As far as I can see, like I mean, I don't know. I have to win this game with a knight. Blockade these pods early. Yep, there's no way you could save that, brother. I think I just like march, 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 march. It's over for you, brother. I probably had like a chance to mate him or something. Oh wait, no, that's not what I meant to do. Abort, abort, abort. I won't play again. Fuck that game. Back to this prefix something. Let me get a snack, some chips or something. All right, back to work. Cost 10 to go from B. Oh, D to B. Wait, to go to from D to B, forward, just look at D. A, B, B, C, D. And then B cost. Wait, what? Yeah, I don't know. Means going from 15 minus 10. D to B. You want to go from here to here. 80, 15 minus minus 6. A, B, C, D. 15 minus 6 is 9. And plus price it takes to go from A to B plus 1 equals 10. Is that what they did? So I guess the wraparound means like from the cost to go all the way around the array costs 15 from A, wrap all the way around A. But if you're going from D to B, you need to wrap around. We need to compute the wraparound cost is 15 minus how A. I'm trying to understand this shit. Minus A to B. So the full wraparound is 15, and the cost to go from A to B? No clue, dude. No clue. And the cost to go from A to D is 6. So you subtract it by 6. Where it go from Yeah. Now walk physically from D to B. We D E A B. So D to E costs 4, E to A costs 5, and A to B costs 1. What prefix functions are actually storing? Your prefix sum is storing. Your prefix array is answering one question only. It's asking one question only. How much does it cost to go forward to some letter? So next cost I costs to go from A to whatever I is forward. Okay. A to B costs 1. From A to C costs 3. From A to D costs 6. Yeah. 10. 15 is the total cost of one full loop, not a real letter. Okay. Now, logic behind the formula slowly. We want to go from B to D. Split the journey into two obvious pieces. From D, E, A. And then A, B. The prefix sum knows A to D. From A to D costs next cycle of 3, which is 6. Yeah. Cost of A as a full cycle is 15. From D to the end is a full loop minus. Okay, this is where I got confused. So if you know that this whole entire thing, traversing this whole entire thing, costs 15. But we want to know what's the cost to go from D to A or some shit? D to A. From A to D costs. All right, so we know that the whole thing is 15, and from A to D alone costs 9. A to D does not cost 9. It costs 6. Yeah, it costs 6. It costs 6. From A to D costs 6. So what that leaves us, like ABS, is 9. What does that tell us? Lord, I have no idea. So from D to the end Oh, because what does this 9 thing represent? So from D to the end. So go from D to the end of the array costs 9. Okay. Okay, so the whole entire cost. The D to the N. D to E, then Yo, how the this is where I get so lost. So we want to figure out how much it costs to get to the end of the array from D. We know that to traverse the entire array it costs 15. And we know to get from D to A costs 6. So everything before it. Oh. Okay, okay, that makes sense. Now we need A to B. Take a simpler physics on problem like range some queries. Okay. Okay. Just say words or numbers, no code. If the full loop is 20 and A to C, it costs 13. Wait, so Alright, we're gonna try that. Bro, okay. You have 2 remaining slots. All the good memories. Leetcode 303. Oh yay! I have not solved this. Put our massive brains to work. All right. Given an integer array nums, handle multiple queries in the following type. Of the following type, calculate the sum of elements of nums between indices left, right, inclusive, where left is less than or equal to right. Implement the numArray class, or numArray int. Where numArray int nums initialize an object with an integer array nums. Sum range returns the sum of the elements between indices left and right. Oh, inclusive? Okay. Okay. Prefix equals array. Then yo, chill. Trying to get me in trouble. Jesus Christ. Okay. So we have -2, 0, 3, -5. So between 0 and 0, there's nothing in between 0 and 0, so just be 2. So range sum 0 to 2. It'd be 0, 1, 2. So that should go -1. That should go 1. 22. I'm guessing so the array should just be like -2. -2, 1. Wait, hold on. We might. I think I got too antsy. Let me comment this. Let me check this. So what would our prefix sum look like? I'm guessing it would be like -2, -2, 1, -4, 2, and 1. Some shit like that. So what do we do with this information though? Prefix sum. This is so if we were to ask what is the range sum between 0 and 2, we know what the range sum between 0 is -2, and then the index 2 is 3. So you subtract them or add them together. We'll subtract them. So the left bound minus the right bound minus the left bound, that would be 1. Why does this make sense? I know it makes sense because I just trusted it, but it's the range sum of 1. Wait, because you know that the range sum of right has nothing past right. And you know the range sum of left, well, it has right has everything from 0 all the way up to right. Oh wait, I'm tripping. I'm looking at the wrong array. So if you look at, say, if they ask for a range sum of 0 and 2, obviously we'd have range sum of 0 is -2. Range sum of 2 is 1. You add them together, you would get 1. Because this is saying everything from starting at 2, ending at everything from 2 and beyond and behind. Yeah. What about 2, 5? 0, 1, 2, 3, 4, 5. Actually, go -1. I feel like it makes sense to just get the bigger one. You can't get the absolute value. Something doesn't make sense here. Do we need a left and a right prefix sum? I don't know. So let's say between 0 and 5, you would just return 1 because I must have. Yeah, this is so wrong. This should be -3. -2, actually. And from -2 plus 2, this should be 0. This from 0 to negative, this would be -1. That makes more sense. Funky math going on there. Wait, why did I do that? I keep looking at the wrong shit. Yeah, I think that is -4. And from -4 plus 2 would be -2. And from -2, -3. Perfect. That makes, I think that's correct. So what math did we do here to get from 0 to range 5? We just grabbed the upper bound. I feel like we need a right and a left, though. I feel like that would make the most sense. Because this is just calculating the right, so we can obviously calculate. From this is just going one way. I don't feel like you can actually figure this out with the information here. Zero 5. You have to know every number from 0 to 5. So you go to the 0. 5 would be the right presum. So -3. And then you have to get everything from the. This is kind of hard. I hate prefix sums. What the fuck? What does this mean in simple terms? I feel like I'm overcomplicating this. In simple terms, if you have an array and you have the range, you want to get everything inside of that range. So what does that mean? Everything to the everything. So from here, we want everything from 5. I think we need to reverse this, right? Because we want to go. We want everything from the left of 5 to left. So in this case, 5, and then we go all the way to 0. The accumulation of all of this would be -3. If we go 5 to 2, we want everything from the left of 5 all the way to index 2 here to be -1. So instead of having a prefix sum that goes like this, what if we had it backwards? Do I need 2 prefix sums? That's the question. I don't really know. I have no clue. Am I stumped? Why are prefix sums so confusing to me? What does this like fundamentally represent? The accumulation of all numbers from 0 to I, right? Yes. With this information, what can I do? We want to figure out the range of 2 to 5. 0, 1, 2, 3, 4, 5. What do you have to do? I think you would get the accumulation of all the numbers. So like 3. So you get like -3. Oh shit, Prince is back. Call this dude. Oh snap! I have not seen you with a camera on like months. Dude, I was trying to figure out how to do prefix sums. This is an easy question. Of course, it's easy to brute force it, but I'm gonna send it to you. I'm trying to figure out how to deduce the answer with prefix sums. No, no, I'm burnt. I'm burnt out. Not even. I'm just like frustrated at prefix sums. I cannot be defeated by such. Like this is an easy problem. All right, so think. All right, uh, no, no, no. I decided to try it easier. Oh, I didn't even try this. I'm trying to figure out how to do it with prefix sums. I just looked up easier because the question we were looking at was a prefix sum question, but it was hard. So I think it'd be good to try easier ones than build. Go back to the other one. No, and I wrote this. It's a whole nother problem. You could ignore that. I don't. I was thinking about. Well, first read the question. I'll tell you where I'm at. Yeah. Yeah. Yeah, that's how it feels. Because there's no point. Like we already know it. Like we're not gonna learn anything from that. Because like I'm sure you know how to like iterate through an array and add numbers. Like that's like easy mode. Yeah, I looked it up. It said that prefix sum is like basically you have the accumulation of all the numbers. So you see, I made a prefix sum of the accumulation of all numbers from 0 to I. So this represents from I to I. I mean 0 to 0. This would represent 0 to 1 and then so on, right? And I'm thinking, how can I use this to derive the answer? Does that make sense? Like what this is? Yeah, this would be like my prefix sum. And I'm trying to see if I could use this to figure out the answer. I just looked it up. I just looked it up and then was like can't be too hard. And then I've been here for like 30 minutes. But I think it makes sense. Like think about this. Like let's look at the range query 0 to 5, right? All you have to do is look at prefix sum at index 5, and then that's the answer. Because you see example 1 is -3, right? And then same thing for 0 to 2. You just look at the index of 2. 0, 1, 2, it's 1, right? Now the question is, how do we figure out 2 to 5? Because with this, yeah, I'm saying, so how do you do that? What do you mean by that?
How do you do this? But this would say that, you know, we have the answer of this, so let's just subtract whatever this is
Oh, what's up, man? We're
to
locking
get
in right
this.
now. It's been here
Since we have the
grinding.
total of everything here, we subtract the total of these two things that we have here to get our answer.
Yeah.
But I don't
Yeah.
feel like that's less work. I still feel like that's
No, wait. No, because that requires you to iterate through a whole array.
yeah, prefix sum definitely still starts at O of n because you still needed to do this whole thing.
No, no, no. From what I learned of prefix sum, you do O of n in the beginning, pre-computing everything, and then
Yeah.
figuring out the ranges would be O of 1 because you already have these pre-computed values.
Oh, well, we have not figured out the O of one part yet then because
Because no, we have. Look. So how would you so look at the 0 to 5 one range, right?
yep.
All you have to do is get the index of the fifth indice in our prefix sum thing, and it's -3. That's O of 1 operation.
Yeah, I get that. But the reason that works is because we're doing from zero.
Yeah,
If we don't do
exactly.
from, then it breaks. So
So I
like,
think we need another prefix sum that goes the other direction, and then we could subtract them. This could be considered the right prefix, and then we need a left prefix, and then we could like do some math on them, and then get the answer in O of 1.
okay, let's try it.
All right, so this is the yeah, because I tried to figure out how to do this just with a right prefix and it wasn't working. And yeah, I think we're just gonna have to make a. So let's just call this like right. These are notes, so like don't like look at that seriously. And then left would be, what would left be? That means we'd be going through the array backwards or something. Wait. So this would be 0, right? Because everything to the left of the first. Wait, no, it's inclusive. So I think this should still be -2, right?
I don't get it. I don't get it at all. So
Wait,
like
CC.
if
Okay,
so so if we're going from the right, what do you mean -1? I mean from left
-1.
because left is the last index.
Oh no, not like that. Like you see how this is right because it's. Wait a minute. No, this is left. I'm tripping because like this first index 0 will represent everything from index 0 to the and left, which is nothing. This should be right. Does that make sense?
Okay, yeah.
So if we did right, then we would have to figure out everything from. Wouldn't this just be the reverse? I'm geeking right now. This does not make sense.
Yeah, it would be the reverse. So like it would be the total, which is -3.
I feel like this is so stupid. There's no way this is about to end up in anything good. Is this correct? Just literally the reverse of this? I don't know, man. Seems fishy.
Wait, -3. Then you remove. Yep, it's the -1. Then you remove 2.
Can we do like an example with
Wait,
positive numbers?
wait a second. Let's make sure this right thing works. -3 is correct for sure, right?
Yeah.
Because that's the total. But we take out the -1, we get -2, right? That's for sure, right?
Yeah.
But if we take out the 2, how do we get -4? -2.
-7 minus 3 would be -4.
What? No, but we were
Because
at -2, right? Before, right?
can
Here,
we make this
and then we.
example more simple without negative numbers? I feel like that's overly complicating it.
Bro, we should get this. We should get this. It's just
We're cooked. Like, yo. I mean, you're fresh. I've been here for 30 minutes already.
You want to take a break? Sure, take a break.
Nah. I'm just saying, like, all right, are we even on the right track here?
Because we're saying that so we're saying like this is the total, right? So we could just do this. -2 plus 3 is 1. 1 minus 5 is 4. Oh, that is correct. Okay, yeah, that's correct. -4.
So if we want to query 2 to 5, that means we want all the numbers from. Wait, can you remove your highlight real quick? 0, 1. So 2 all the way to the end. So we need to know, if we know that 5 is the whole entire array, can't we just subtract whatever is from like behind it? So like left -1. Because if this is the accumulation of all these numbers, can't we just get the whole entire array minus these two numbers? Right? Like, so -3 is the whole array. And then we know that from 0 to 2, if you want to, no, 0 to 1, because we need to get rid of these numbers, would be -2. So -3 minus -2. Won't that become a positive? So is it 1? Is the answer 1? What's the answer? Fuck, it's -1. Are we close? Or did I do the math wrong?
I understand the math you were doing.
All right, wait. So, all right. So the range 2 to 5 means we want all the numbers here, right?
Yep.
So, and we know that our left presum at index 5 is the whole entire array, correct? Now, all we have to do is subtract the numbers from here, and that'll be our answer.
Yeah.
Because this. So, what holds all these numbers? That would be the presum at index left minus 1. In this case, left is 2, left minus 1 is 1. So you go to index 1, this is -2. But something funky happened. This is supposed to equal -1, but I got 1. I think I messed up the math, but I think the logic is correct.
But that would only work if this was like from 2 to 4, then we'd still have to include this 5 here. How do we get this?
Oh, good example. Good. All right, so 2 to 4. 0, 1, 2, 3, 4. Oh, yeah. You literally just look at index 4, and that would be the accumulation of all the numbers from here, and then you should subtract 1 minus the left. So that would be -2. Yeah, because we want to it's inclusive.
So 2 minus 4 is this, and then we need to subtract this.
Yes. We don't have to subtract that because our prefix sum already doesn't have that inside because we're going at at the right index. That's -2. It only includes -1 if we go to 5, but we're not using 5, so we don't have to worry about that. You feel me?
Yeah. So we will check the ending of this to see if this is included.
Yeah, to see everything from 0 to the right. Wait, yeah, you say it. I think it'll lock in more.
And then we're gonna take out the beginning as well.
Yeah, we have to take out. So left -1 will be everything from 0 to left -1, which is what we want to remove. And that should be our answer.
If we took out this manually, it would still not be O of n, right? I mean, O of 1. So maybe
No.
maybe we do this minus this somehow.
That's what I'm trying to do. But why is this 1? It's supposed to be -1. Like, did I do the math wrong?
-2 -1 -1 is -3.
Oh wait, my bad. This is for the 2 to 5. But because we know the answer is supposed to be like the 2 to 5 one.
-3 -1 is -4.
What? Where are you getting 1 from?
2.
No, you have to go -1 again though, because that we include that. So -1 because it's inclusive.
So why do we start at 5 then?
5 is just the entire array to the right, and then you said -1, but this is including inside of our array. We don't subtract that. We don't subtract left -1, which would be right here, because 2 is included in our range that we want to return.
Okay, let's go with that for a second.
What do you mean go with that for a second? That doesn't make sense to you?
I mean, I don't know if it works. Like we're just avoiding the 5. It's like saying that because the 5 is the entire array.
We're not avoiding the 5. We're using the 5. That's what the -3 comes from. We got that because we have a 5.
But it's if we're following that logic, why are we not following that exact logic? Because like for me, the 5 is like the end point in where we stop. but you're saying that's not why we're using the 5. We're just saying that because that's where the 5 ends.
Wait, no. Oh, maybe I misspoke. Yes, it is. We use this because that is the endpoint. So like, if this was 4, we'd go to the 4th index. So this would be -2. But just since it's 5, we use 5. We use the -3, and then we want to subtract. So if this encompasses from I,
Continue.
so if this encompasses from 0 to right inclusive, right? And we want to figure out the range between left and right inclusive, we need to subtract left -1 because left is 2, which is right here. We don't want to subtract any part that's 2 because that's inclusive in our range. We need to go -1, and that would be everything from here, right? Right?
Yeah, so we want all of this minus this, right? That's what we said, right? That's what you
Yes,
said.
yes.
Yeah. So like why don't we get the total of this, which we do know, which it's -2,
Yeah.
minus the total of this, which we don't know.
We do know.
How about
Wait, no. That's what we're trying to compute by subtracting them.
exactly, yes. How about the total? What is this minus what is this?
Yeah, look at this. What do you think these numbers represent?
Oh,
But I got 1, but it's supposed to be -1. Am I just bad at math? I think I'm bad at math because the logic makes perfect sense to me.
this is -1. This equals negative. When you do a negative minus negative, this turns
Oh
into a
shit, I'm
positive.
tripping. That makes perfect sense, bro. We don't even need a left and right array. We only could use the one the one left one, and we could actually compute this right now, right? Just with that same logic.
Yeah, let's try others because I'm not fully convinced yet.
Okay. So do 4.
Let's do something that we know what the answer should be. So like in the
There's
example
no
we
more
did,
examples. We
0 to
did them
2,
all.
0 to 2, which is still not really helping us
Just do
understand
0 to
anything.
4. It's not like we know math. Well, you know math. I messed up last time.
You still not- Stop. All right. So yeah, let's do like 2 to 4 because I think that would
Okay.
really help understand the problem fully. So 2 to 4, the answer should be our range should be like 3. Uh, yeah. So I'm gonna do it
5.
manually before we do it the trick
5,
way.
right? -5 because
Three,
4 and 2
minus
-6 minus plus 1.
5, -2. This is 0.
What?
This
Oh, I was
this is
looking at the wrong array. I'm tripping. Yeah, you're right.
so the range is 0.
Okay.
All right. So this is what the answer is for this one. So let's see if we can figure out how to get 0 from this. So
Okay.
we would do like this is our uh, range right here, right?
Yeah.
So we
So we
take
get
the
4, which is 0, 1, 2, 3, 4, -2.
-2, and then we said the one previous of that.
So 1. So -2. Yeah, -2 minus -2 is 0. Let's go. You look like you don't believe it, but the math is mathing.
It's math, right? Like it's so surprising that it works, bro. It's so surprising.
I think we
I
should
was
go
like,
for it.
my
It's an
face.
easy problem.
That
It,
was like, I was like, is this magic in my head?
I mean, I've been thinking the same thing for the last 40 minutes, man. Like, this is the only breakthrough I've had. So I think we could do it, right?
Wait, what was that algorithm? I'm gonna write down that algorithm just now so I can really understand it. So it's
So do
uh
prefix of right, because prefix is going to be our whatever we call this array. So prefix of, and then for the index, just put R for right. Minus prefix of L -1. Hell yeah. So I think to make the prefix, don't we just have to like do like total plus equal nums of I and then do whoa, what just happened? Okay. Prefix dot append. Prefix dot append just total, right? I'm pretty sure that will give us what we want. Then when they give us a range, we just do like return self dot prefix of right, which is a number, minus self dot prefix of left minus one. I think that I don't know, man. I'm gonna try it.
Yeah.
Nope. What happened here? Did I spell a pen wrong? Wait, are these strings? Some issue. String object has no attribute append. Oh, self dot prefix. Wrong answer? Are you kidding me? I think I had to compute the prefix wrong. There's no way the math is not mathing. Print self dot prefix. Okay. Oh, it's empty.
Well, you want to print your stuff.
Oh, yeah. As you can see, yeah, I need my break after this. Okay, -2, -2, 1, 4. Yeah, it's correct. So why is this not right? Prefix of right, which is a number, and then minus prefix of left minus 1. And what? Yo, what?
I hate that they don't say the range. They just say some range. They don't give us the actual range.
No, they do under it, but I guess you have to like match it up though.
Where?
Look at input and then.
Oh, I see. Okay.
Bro, what? This is the same example we just traced. So why do we get 0 and they expected -3? So for the last one, it's
Wait, which one are you looking at? Negative.
case. There's only one
Oh,
case.
for the first one, we're already wrong by the 4. Why do we get
Oh, yeah,
4?
we could look at that one too. So 0, 2. How the no way, dude. From
Oh,
0
I
to
get
2
it.
is not 4. Oh, because -2 plus -2 is 4.
This
Oh.
our left is
Wait, negative.
0. So if we go 0 minus 1, that's a -1. That brings us all the way to the back of the array. We're saying go to the back of the array, which is super wrong.
Oh,
So,
yeah.
so maybe that's an edge case we could easily fix. But before we try to fix that, um, let's see what happens with the 0. Why do we get 0? So from 0 to
Okay.
5, um, that should just give us, that should just be the last index, right?
Yeah.
Oh yeah, but once again, we do this 0 shit with the self prefix
Yeah, I
left
think
minus 1.
that's the issue.
We
So
can-
all we need is some
Yeah,
if
so
condition.
yeah, don't do that.
If left equals 0, I know this is like probably there's a probably more beautiful way to do this, but you know what? Doesn't matter. Of course, I didn't put two equal signs. Come on. Come on. Are you kidding me? What? What? I'm getting bodied hard. The math was making so much sense earlier.
Wait, if left equals 0, we just need to return the right, no?
Oh. Oh, wait. Is that so you're not supposed to actually do anything else? You don't subtract anything?
Because we're doing from a 0. Yeah, the prefix should tell us this, right?
Oh yeah, because we did -1, which should be 0, but yeah. That makes sense. Yeah, it worked. Let's go. Good catch. Whew. All right, and it's really fast, so we know it's we prefix summed it.
Prefix something.
Yeah, it would have been
With,
all slow if we did O of N. All right, I'll
with the
take
print.
that. Oh yeah, with
Yeah.
the print statement. Let me let's take that out. Submit again. Oh yeah. Oh yeah, 3 milliseconds. Prefix sum is making slightly more sense. It says ChatGPT gave me another problem to do. It said 1480. Because like that took probably way longer than it should have for an easy problem. 1480. Running sum of 1D array. I already did this problem. I don't know if I saw do it a prefix sum though. No, I'm not doing that. What's another problem? Find pivot index. I think I did that too. All right, you wanna maybe we should just go back to that problem we were stuck on.
What problem?
The one the prefix sum one that we solved, but like I think it was shifting distance. Yeah, this one. But I gotta take I gotta take my break because
Okay.
I'm fried. But you join the question, you could like reread it to get caught up. I'll be back in like 5 to 7 minutes. All right, boys. I'm taking a nap. Take care, brother. I'm going to go to sleep. See you tomorrow. All right, peace out, man. Appreciate you showing up. Appreciate you. I'm on my 5 minute break. I hope y'all doing good. Oh, let me do your push-ups. Yo, guy, are you still here? Guy that I owe your push-ups to. Wait 1 sec. Wait, guy that I owe your push-ups to. Are you still here? I don't know. I'm gonna still do them though. Oh my god, it's hot. Oh, what's up, Jit? You doing? I know what you're not doing. Eating dip song. Dip song. I feel about 5 minute break. That's not my 5 minute break, girl. Say you want to come over? Sachin's cousin, sister. To do what? That's all about studying, girl. You're not studying? Just study the next year's material. But you should bring your chain so you could like put the necklace on it if you want. So what? Use the chain of your old necklace if you want. Yeah. So but it's raining. I don't want you to get like wet. Yeah. Wait, what? You gonna show it to your cousin? Let me know how that goes. You said you get them push-ups. What the hell? Yo, when people subscribe, it doesn't even show up no more. It's kind of mad, sad. I'm gonna make it pop up. My alert box is broken. Get back. Tofu. I think I need some sauce. Damn, I need to thaw some of that shit. Wait. Don't they always do that by their house? They weren't going to? Like have no party at all? Have fun with that. Oh, I'll let you know. We got time, a couple weeks. Anyway, peace. Pookie. All right, bye. All right, I'm back. Yeah, I'm energized and I'm ready. What have you learned?
Oh, I was not paying attention.
Oh, but nah, it's good. You should take your break. All right, so let's get back. So what we did before was doing a whole bunch of shifting, and this is a prefix sum question. So I think we should have, since there's, all right, so we both get the premise of the question. So I'm thinking maybe we could have like a next pre-sum and a previous pre-sum because they both have a different cost, right?
Makes sense.
So the question is, what should the pre-sum have? Let's like make a tiny alphabet because the 26 is kind of hard to think about. So let's say we had like next equals, and then we had like 1, 2, 3, 4, 5, and this would represent A, B, C, D, something like that. I don't know how to go back. Like, I don't know, whatever. There we go. So in order to go from A to B, it costs 1. From B to C, it costs 2. Yada yada yada. The question is, what does our prefix look like? Next pre. So from A to B costs 1. So I think that would be like the first one. Because if we queried A, we get 1, right? From A to B, no, from A to C, how much does that cost? Does this even make sense? A to C would cost 3. So you got to get those good viewing angles.
It's just turning up. Yeah, it's turning up.
And then A to D costs 6. So this is B, C, D, and then A to E costs how much? 3, 6, 10. And since we can wrap around the entire array, the how much does it cost to like for the whole entire array?
10 plus 5, 15.
Yeah, 15. I hope this makes sense. Okay, let's pretend we're doing something where we have to go forward. So first example, we want to go A to B. We could query. We do that whole like ASCII stuff, and we see that it's a difference of 1. So we can go up 1 position. So we check, hey, next prefix at index I, where I is A, would be 1.
Let's simplify it a little bit. So, like, if we're going from A to B,
Yeah.
our range is just 1 to 2, right? We saw in the last example that since if we're starting from the beginning, we don't necessarily need to do anything with this 1 as like an edge case. So we just need to get the 2 value and then just return it, right?
No, because when
If we're going
wait,
from next, if we're going for next.
but when oh the 2 value. Wait, but which none of those equal 1 though.
So in our example, since this is in exclusive, we could just take the previous value.
Wouldn't that just be the index of whatever the s is at, the s of I, which would be in this case 0, and then just go to next to 0?
Yeah, so I think a better way to think of it for generalability is just 2 minus 1, or b, the last one, minus 1.
B minus 1. Yeah, yeah, yeah. Okay. Let's think about something bigger. Like, so A to E, what do we do? A is at index 5, so no, that doesn't make sense because we pick 15.
So
Oh, wait,
a,
minus 1
yeah, minus 1, which
would
is
be
10.
10. That makes sense. Okay. Okay, now let's think about what if you wanted to go from D to B forward?
D to B needs to encapsulate this, and you said D to what?
B. I wrote it up here.
Okay. So we know there's one range here, which includes all of these. So we know how to get the difference of what this is, right? Or do we even care?
When you say this, what do you mean by this?
Like, 1 second. Can you hear me?
Yeah.
All right. So like, what's the saying? All right. Yeah. So it needs to check. We need to get like all of these in here, right? Like from, we need to go from D to E first, and then
And then wrap around from A to
A minus.
B. Wait, so what's the
So
answer? What does this equal? So
uh,
D to E would be 4, and then E to be 9, and then A to B would be 1. It would be no wait. Is it 9?
10, 10.
10? From D to B is 10. Okay. So how do we figure that out?
So from our last problem, we understood that to get this range, we would take um, our ending minus this, minus left minus 1, right?
Yeah.
So 15 minus 6 is 9. And then we have another range of A
Oh,
to
A.
B.
Oh,
Yeah, not
so 15 minus 6 plus the other one.
1.
So it's just 15. So it'd be like 15 minus 6 plus 1.
Yeah.
Huh. And what's the plus 1 formula? Like from. Oh, wait, just look at B. Oh my God, that's so genius. 15 minus. So it'd be like. So it's basically like the full loop minus.
Not necessarily the full loop, but where the left ends. Oh, which is, yeah, it would always be a full loop. You're right. Because if, I mean, we would need to check to see if it goes to full loop. We would need to see where our, so we would need to verify our right. Like, what is our right going to be like? If our right would take the full loop, if not, uh, do extracurricular.
That's a simple if condition. It's like if left is less than right, because that means you have to go around.
Yeah.
No, if right is less than left. That's what I meant. All right. So let's assume we have to wrap around because this one we do. So we do full loop minus next at whatever D is at. In this case,
No,
D would be
no,
6.
not necessarily. The formula was
Wait, this doesn't work.
no, the formula was the full loop. We could say that for now. Minus um, the left loop, which was D, minus 1, which was 6. So it's where D was the previous one before it. Remember, we're looking at the pre, not this. So 15 minus 6, which is 15 minus 1, which is 6. And then we still need to get the range of where we need to go, not inclusive of um, this. So there could be like several things before we get, so like before this. So uh, for this one, it just happens to be just B. Or, but
It,
there is another formula here that we need to compute from
I don't
like
think so. Because what if it was C? Wouldn't you just pick C? Because it's
I get what
normal.
you're saying. So because this would be until we get to the range of wait, we need to get to D, right? We're going from D to B, right?
Yeah. So we already figured out D to E, which is 9.
So so it would be B minus 1.
Yeah. Yeah. I think this makes sense.
Yeah.
It's, I kind of dislike the whole like -1 thing. I know it makes sense, but I wish there was like, wish we could map them to the indices precisely. But I don't know how to do that. It seems like too much thinking.
I mean, if it works, I'm like trying to break it.
Yeah. Okay, so that figures out. So that's for next. We still have to figure out the thing for
Still think
previous.
we need to understand how this full loop thing works. I don't think the formula would actually say full loop. Is that a thing?
Well, full loop would just be whatever the last index is. I guess if it makes you feel better, we could do next at -1.
No, that does not help.
Wait,
I don't
what?
think those
Wait, what? Isn't that the full loop? Isn't that what we're doing?
because remember maybe we should write the if condition if like I don't know. I just feel like when we get to coding, we're still gonna have to think super hard about why this is. Um, but I guess when we get there, we get there. So
Wait, let's trace it and see what happens if you don't need the wraparound, but we do this. Like, is their answer wrong and by how much? So let's go A to B, right? Like A to B, and we know that is 1. So we do 15 minus.
we wouldn't even need the 15. Why would we even do that? I feel like this only applies if we need to go around.
Yeah, no, I'm just saying what would happen if we didn't. I just want to see like how wrong the answer would be, or what would happen. Because I really don't know. I'm not really expecting this to work. I just want to see like 15 minus and then In this case, it wouldn't be B. This would be A.
No, don't take out our initial formula. Do it somewhere else.
I mean, it's just like variables. It's like this is just pretty much like start and end, but okay. I mean, I'm pretty sure this would be like 15 minus, and we look at our next at the end. So in this case, it would be B. What's B minus 1? 1. So that'll be 14. And then plus next of, in this case, not B, it would be A minus 1. A minus 1 is 15. Let's go, brother. Let's go. It works still. That equals 1.
I was not following along. Let's do it again.
Yo, because he didn't believe. He didn't pay attention because he didn't believe. All right, let me show you what's going on. All right.
Okay.
So our formula is full loop minus end minus 1 plus start minus 1, right?
Minus B minus 1.
Because B is where we end, because we started at D.
Is 1. Wait, is this where we end? I thought this should be A.
No, I was talking about the old example, because you said not to touch it, but this would just be end, and this would be start.
No, this should be start.
No, not at all.
Yes.
Even in the last example, how?
That's what we did previously.
No, because we did D to B, and what was this before? This is B. B is the end.
We have to do D minus B. D
All right.
minus 1.
Is B the start or the end?
Minus 15. D is the start. We should write start.
So what's B? B is what?
We said D to. So this
D
is,
to B.
Right, let's D to B.
So what's B?
Start. End.
And I'm not going to change anything. All I'm going to do is go forward. Wait, no. So I can't go forward because you typed, but you're tripping balls, dude. What are you doing? This is end.
All right. You know what? We could do both. We could do both.
But that doesn't make sense. We just traced it.
No. We could just. But that's not what we did.
That is all right. What do we do then? What do we do, Prince?
All right.
Mm-hmm.
Check it out.
Okay. I'm listening.
So full loop is 15, right?
Yeah.
And then the end. We're doing.
That's what I said. You said start.
Yeah. We're doing an example first. End, which is B, right?
Yeah.
B minus 1 is 1. But we want this to be 6.
Wait, what?
We wanted this to be. This is what we use.
All right. Fair enough. You got it. Start.
Hey, let's go.
All right. You're right. I accept defeat on that one. You're right. All right. So it's full loop minus next of start minus 1. Yeah. Okay. Yeah. You're right.
Okay. So back to the A to B. So we add 15, which is the full loop, minus the next start, which is our A, minus 1, which is 15 again. Once again, we could add an if condition, because if this starts with A, I highly doubt we need to. But anyways.
Wait, highly doubt we have to do what?
Go around. So if
backwards or forward?
No, because 15 minus 1, I mean, a, which is 0. 0 minus 1 is negative 1. So it would it would go back to 15, which makes no sense.
Oh, but doesn't this give us the right answer though?
Oh, but with this algorithm, uh, this would be 15.
Okay, so 15 minus 15 is 0. And then plus end, which is b, minus 1, which is 1. 15. So 0 plus 1 is 1.
15. And then we
Wait, what?
would.
You mean 0? 15 minus 15 is 0.
Oh, yes, sir. 0 plus b, which is 1.
Yeah. So it seems like it works no matter what.
I am very, very pessimistic
I
with
think
this.
if it does work,
Without
that means we just
let's
don't
let's
understand
let's
how it
try
works.
let's try a different one. Let's try a different one. Let's do like just really just A to C. Nothing super complicated.
A to
If it
C,
works for
okay.
this, then it cannot be coincidental. It just works.
Okay, A to C, so that would be, so what's the answer to that?
So this would
It'd be
still
3,
stay at
right?
15, right? And then this would still this will be moved to 6.
Wait,
Wait, wait,
6?
wait.
No.
Yes. Wait.
Wait,
The
what?
previous one was not right then. Because B was 2, and we said it was 1.
Because you have to go B minus 1, start minus 1.
Okay. All right. So then it would be 3. Is the answer still 3?
Wait, why'd you? Yeah, the answer is 3.
Then it works. I have
All
nothing.
right, can we sit, like, why? I don't know why it works, I'm just being honest. Like, why does this work, though?
You want the math behind it?
Or, like, the, not, I guess, kind of, but more like the logic. I think we got the math, we just don't got the intuition. So, full loop, what does that really represent? Traversing the whole entire array. And then,
Yeah, it's super duper confusing how if you go -1 from 1A to 15, this works. Like how does the previous one from A, literally A to 15 still works?
I don't know. I think this is important to know, though. There's no way you could, like,
Full
think of
loop,
it.
because you're always subtracting the full loop minus the start -1. You're always subtracting the full loop minus start -1. So one second. Let's do, because I feel like it's maybe still coincidental. Let's do
He just said it wasn't coincidental. Now he's like, one more.
let's do
Okay.
B to D. Let's see what this gives us right here.
B to
So
D.
B is full loop, which is still 15 minus
Start minus 1.
start
So 1.
or 1. 15 minus 1 is
14.
14. 14, and then plus next n minus 1. Our D is uh, 10 minus 1, which is 6. 15 minus 6
9.
is 9. Is the answer 9?
I don't know. B to D. So B would cost, it would cost 2. No, it should cost 5. Wait, what? Shouldn't it cost 5? I think it should cost 5.
Yeah. All right. Cool. Doesn't work.
Nah, 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 nah. Something's up here. Something's up here. There's no way. We just got lucky twice in a row.
Because we're using A is the common denominator. A, which is the start.
Oh, damn. That's tragic. So it works with A, but anything else, it won't work. full loop minus. Damn. So this works if it's so so what do you do if it doesn't wrap around, you just have to do what then?
Yeah, if it doesn't wrap around, we could just do our normal logic that we did before. Normal logic that we did before.
So D is A, B, C, D, so it'll be 6. And then B is, yeah, so just 6 minus this and 3.
What's the
Hmm.
algorithm?
Oh, you just do like pre of, we just do next at D minus 1 minus B minus 1. So it'd be 6 minus 3 if it doesn't wrap around.
I'll write that down.
Yeah, I go for it. You want me to write it down?
You can write it. I was gonna think about it
Sure.
before I wrote it.
So it's just like, so it'd just be like next of D minus 1 plus, not D, and plus minus next of start.
Oh, we went on the next line.
Oh Lord. Okay. Start minus 1. Damn.
Okay, so what does that said? N minus one. Sorry, N is D.
Yeah.
D minus one is
Oh wait, hold up. I don't think. Wait. Oh yeah, A B C D. Yeah, D would be here minus 1 6.
6 minus start minus one again.
Yeah, maybe not minus
Uh,
1. B A B.
start,
It's
which
just
is
B.
B.
Yo, there's something so wrong with this.
Well, I thought our algorithm was N minus start minus one.
N minus start minus 1. N minus start.
No. So like just N here, and then start minus one here.
So N here would be, so A B C D. That'd be 10 minus start, which would be B. No, that'd be 9 then.
And our answer is 9, no?
That's how much it costs to go to B to D.
Wait, from B to D?
Wait, is that what we're looking at?
Yeah. I mean,
Oh
that's
yeah,
what
there's
we're
no
looking
way
at.
that this doesn't cost 9. It costs 5.
Oh, because in our example, in our previous example, it was inclusive, but now we're not inclusive. So maybe we do need the negative one. Yes, that's why we need the negative one. So if we do N minus one, in the previous problem we were doing, it was inclusive. But now since it's not inclusive, we take it out because it's not inclusive of what the range is.
Yeah.
So yes, so N minus one is 3, and then 6
Yeah.
minus
Minus
start
start, which is B, minus 1. No,
which is
no, it
1.
can't.
6
That.
minus
Yeah. Oh
1
yeah, it's
is
5. Yeah, yeah.
5. Cool.
Damn.
You got everything?
I
So
hope
we need to
fucking
identify.
pre
We need
is
to
the same
identify
logic.
when we need to do this formula. So we do this formula if the difference is a negative number.
Yeah.
I think. Right? That makes sense. If the
If
difference between start and end is a negative number, then we apply that formula.
yeah, we don't have to even calculate difference. We could just say if The ASCII number of end is less than start,
Yeah.
then we do that. Otherwise, do this. God damn, this is how is this a medium problem, man? I mean, it is.
Yeah.
Oh yeah, but the prefix is like it's kind of annoying.
I really feel like this is like some kind of test that will come up on the interview. No doubt.
Yeah, and of course their code will like not let it pass if you do the manual way, which is so intuitive. So
You gonna start it?
I'm just thinking about this one thing,
What one thing?
like our prefix array has 1 for A, that's going 1 to B.
Wait.
Wait. If this started off with 0, does that fix like why we have to do -1? Because now this just means that going from A to A is 0, which would never happen. Wait, actually, yeah, it would be. And then in our for loop, we could say if we don't have to even have a condition to say if the index of S and T equal the same thing, because they would just check the prefix at here, which is 0. And then we don't have to do -1 and -1 here, because they actually line up correctly.
Oh, you're trying to solve the -1 issue?
Yeah, and like I think this fixes the -1 issue, and we don't need the condition to say if like S and T are equal, then continue, because it would just get this one, which is 0.
What? If S and T, say that again?
Like if we're iterating through S and T and they're both equal A, before we have to say if S and T equal each other, continue. But if we have a 0 here, it would look at the index here, and then wouldn't it be 0?
If S and T are equal to each other?
Yeah, like if you look at the first example, if they're both A, what would happen?
You would move on?
Yeah, but if we just put a 0 in the beginning, we don't have to move on, because we could just do it would just look at pre at A and then subtract pre at end.
What is the problem we're solving? We're not even doing any calculation.
But now we don't have to have any ones. Like they actually match up correctly. Like this, now that works. And we don't need the if condition to say if they're equal continue. We just like the line, we just like less coded right now.
Why would we even write that? Why would we even write that? It just does it automatically.
It doesn't do it automatically. We have to write if they're equal to. So if we didn't have that, how would it know to not do anything?
Because they would be equal to each other, like you said.
Oh, yeah. Wait, so if it was A and A, all right. So let's say it's A and A. If we go end -1, it would be 15. Start -1, 15. 15 minus 15, 0. Huh. Yeah. Yeah, maybe. Whatever. We'll just leave it out for now. Okay. Does the previous, because we need a prefix sum for the previous, is that the same shit?
So we start coding is what we're doing, right?
I'm saying, do we no, don't we need that? It's like for prefix sum, don't we need to make a prefix for the next previous?
Oh yeah, you're saying we do it for both? Yeah.
Are we assuming that the logic works exactly the same? But right? It should.
That I
I hope.
I can't just I can't just like imagine it working. I feel like I would have to do it. So out of faith, we can assume.
Just out of faith, okay. I believe in miracles. Okay. All right, so we first need to create Next pre. Next we need to create pre previous prefix. Then I think after that it's easy. ITERAT. Iterate through SNT with zip. Oh, wait, I think I just have to iterate through previous cost backwards, right? I think so. Yeah.
Wait.
What happened?
Why do you need a length of range? Why can't you just access the variable?
Because I have to go backwards. Wait, do I?
Exactly. That's what I'm thinking. Um, can't we just do this in one loop? Not that it adds a lot more complexity, but
Wait, so we don't have to go backwards to previous. No, I don't think so, right?
I don't
Yeah, I
think
think you
so.
could do this in one. Yeah. Yeah, just do that. But you need two totals.
Yeah.
Prev pre append total two. All right. What do you want to call these? Because S and T are taken. L1 maybe, letter one, letter two. Oh, we need a cost. So now we need to, because isn't that what we're gonna add? Like we're gonna return that then the total cost.
Oh, our res.
Yeah, I should
Okay.
call it res cost. Same thing.
Whatever. Yeah.
Now we have to see if it's more beneficial to go forward or backwards. So
We have to do both. So we can write go forward,
and
go back.
go back. Oh yeah, go back.
All right. So what's our formula here? So uh, okay.
Get the
So
ASCII value of t, and ASCII value of s.
can I name this Andy? If that's okay.
It doesn't matter. Wait, can we just name them start end? Because that's like what we used up there. Wouldn't
But
it
we're gonna
make
we're
more sense?
gonna we're gonna change this. We're gonna do that here equals board.
Oh, or at S or at A. and would be pretty sure just like if the end is less than start, then that means that we have to wait. Maybe let's not do that one first. That's like harder. If end is greater than start, that means we're not wrapping around, right? Is there any way that doesn't make sense? The end, yeah. We just go to what do we do here? Kind of forgot.
Our algorithm says we do next n minus 1 to next start minus 1. If and only if, so we need another if.
Another if? If what?
If and only if the start is not a, then the
Oh.
start is not 0. So we could do it in here.
Wait, can't
No,
we just say
no,
and
no, no.
here?
No, because in some
Oh.
situations we'll still do this.
That's what I was thinking that 0 thing would have helped because we wouldn't have to do that. But I don't even know. That might have break something else. We'll see.
Then we just say our forward total equals next at
Start
end minus
and
1.
yeah. Minus start minus 1.
That's it.
Well, no, minus start. Oh yeah, because it'll be 0. Wait, I think I don't know.
If our start equals 0, sorry, else, and then we will do our. You want to do this one or?
Yeah. I think I'm not a fan of prefix sums. 4 total equals. Okay, so we need. I don't even know why. Why? What the fuck, man? Next
EP is
prev.
definitely much harder than us to understand.
Oh yeah. That coin change problem, brother. All right, so this is the full loop minus.
And minus 1? Wait,
Wait, I
wait,
thought
wait.
we.
What are we doing? What are we doing? What are we doing?
Wait, actually, I don't know. Actually, nah, I'm tripping. Yeah, it's n minus 1 and then minus next. You're right. Was thinking about the wraparound thing already. And then to start minus 1. How many places it costs to get to the end minus how many places it costs there. Else we do our glorious wraparound. So I guess
Ooh,
next pre at
so
negative.
that's like.
Next pre at -1.
Minus.
Minus start at -1 plus end at -1. Oh, n minus 1.
What is it? Plus or minus? Plus.
Yeah. No, it's my wait. Yeah, it's plus and then next pre at end -1. And to go backwards.
You need all of this thing.
Wait, why? Doesn't it stay the same? We didn't change it.
Oh shit! Yeah. Okay.
I mean, we need the forward
So we
total,
do
but
need it.
not the rest of it. So if where so the backward isn't it pretty much the same thing?
Yeah, because I mean, unless I'm understanding, I forget how the problem works. We would still go the same direction regardless, right?
Yeah, because we have two prefix sums, so we don't have to like go backwards and I think it's literally the same thing.
Wait. So if it's the same thing, we don't need to do another formula then. We just add the, the totals in
Wait,
there,
is it the same thing? I'm hoping it's the same thing. It's kind of really what I'm saying.
right? Then we just add we could just do this here, and then
Wait,
we
can we
do
do
this
like a
here.
little trace of going backwards just one time, just see what's going on here? Because I don't know. Unless you just know.
I
So
mean,
let's say we
if
want to go from B to A. So that's backwards one.
what example are we doing?
Oh, I was looking at the first example. Like, if you want to go B to A, that means you would have to look at the 100, right?
We're going from B to A, going backwards for using previous cost.
Yeah.
It would be 100, right?
Yeah, it would be.
Wait, does that track?
Now, I feel like that's wrong because our previous cost, like, scroll up to like line 13. Didn't we just add the like accumulation of all of them? So wouldn't that be 101? I feel like there's something not right there.
Nah. We accounted for that.
Oh, because we're going to
Oh my
subtract
boy,
it?
this takes so much brain power. My goodness.
That means we're learning, you know?
Right.
All right, so B to A. So what would happen here?
All right. So from B to A, we're saying that in our formula here, we're not gonna do this
Yeah, we're
part.
going to be
We're
in the
gonna do
else.
this.
That seems, oh no. It's no wrapping around, but this is going to wrap around. I don't know
So
if
we
that's
need
going to
more.
fuck up the answer.
Yeah, we need another condition. This is not good enough. I feel like I need five.
Yeah, I mean, I had the timer on. We only have 3 minutes and 40 seconds left anyway. Or have to break. Dude, this is like, are we even on the right? Like, it's because we didn't trace the previous. That's why we're confused here. We literally got up to exactly where we like thought about.
Okay. uh, so yeah, so we're saying that if end is greater than start,
It is if we're going backwards from B to A.
oh, so then we are doing this. If start equals zero, or start does
Start
not
does
equal zero,
not.
so then we're gonna
Its
do
start is
this.
B.
So then
Yeah.
we're gonna do next pre, which is the n, which is b minus one, which
Wait,
is
so what would
one.
that equal? That'd be 101 if we're doing previous spree.
100 minus one is one.
No, it'd be
I mean, not
101.
100.
That's what B would be, right? Oh, wait, no?
We're doing previous costs, right? We're doing previous costs. Are we looking at previous costs?
Yeah.
Next cost. Yeah. So end is gonna be minus one. So this is gonna be one, no? The value of this total is gonna be one.
Oh, because B would be 2, minus 1 would be 1. Yeah.
And then our
Minus
next clue would be
start,
start minus 1.
which is A. Oh lord, that's just going to be the whole entire accumulation of the thing.
Yeah, yeah, which is what we need to do actually. We need to go this way.
So the
Right?
accumulation of the whole thing
B
would be
to A.
101. Yeah.
B to A. We have to go this direction and then this, right?
Yeah. So this would be
So this would
101 because all
yeah,
zeros and then is
101
100.
101 minus 1 is 100. Is that the right answer?
It is. That works in that one
Let's go.
example. Let's just assume that works, and if we get proven wrong, we'll be back at the drawing board. Okay. Okay. So what's that thing? Prev total? Do we have a prev total? No.
What?
I don't. We don't have a prev total anywhere, right?
We have a forward total and a back total.
Oh
So
yeah,
I
that's
think
what I meant. Back
back
total.
total is
So back total equals prev pre at n minus 1 minus. I hope it's not one of those things. Remember how it was only right because we started at A and we're looking at this example as A. I hope it's not that issue. Cosplex equals the min of, yeah.
you got to do it for the else as well. The other else.
Oh, so the else is if the start is greater than the end. So what's a good example of that?
So right here. Well, we got to do it for every condition. So you need to do it here. Yeah.
But doesn't it change though? Or wait, is it? Oh, it's all the same. Is
Yeah.
whatever we
Yeah.
have there. Oh, boy, oh boy, does this make graph problems seem fun?
It is fun.
This is fun to you?
Oh, this is a graph problem?
No, I'm saying this makes graph problems look fun.
And graph problems are fun. Just in general, before this ever existed.
He said even before
Let's
this it
solve a
was fun.
problem.
All right, fair enough. Back. Okay. Does this work? Does this work? Fuck it. Fuck it.
I feel like a super trace if this, because we didn't really trace this. I feel like we got exhausted.
Runtime error. Prev. I think I just spelled something wrong. Yeah. Yeah. PR. I think that's. No, there's more. I think I copy and pasted it. Okay, I fixed them. Output 202 expected 2. Nice.
Oh, we close.
I don't
Come on,
even.
really.
Damn, son. I feel like there's probably like a simple way to do the prefix sum, but we tripping.
I mean, I vaguely saw the answer, and the the top answers were not like simple things. They were like super bleep blop.
Damn it.
I was in look better than the actual solutions from like, not that I read it myself. It just so far. I don't think we're far away from the answer. We just gotta trace this really. I just need a break
All
from
right, fair
numbers.
enough. Yeah, I'll put on the timer. Oh, brother.
Have you heard back from about the Airbnb position or anything?
No, they had this thing for like they started mentioning something about an internship, but you have to be graduating in 2026, and then I haven't heard anything
Mm,
back about the apprenticeship. Yeah,
mm.
they said February, so I don't know. It's been waiting. Hopefully, they say something.
You have any conferences coming up that you're going to? Or like,
Nah, just that last one I went to. No more.
How you feeling?
Uh,
Not ready? Then we're fine.
yeah. I fucking hate this problem.
Okay.
Like,
You
it's
want to
so
move on?
much
What
harder.
do you want to
No,
do?
I can't like quit now. Like I ain't say I'm gonna
Okay.
quit. All right, we're back.
So I feel like a good print statement would really help us understand where we went wrong.
Okay. We need to print the forward and backward cost, I'm guessing, or backward total. See like what's going on there.
Okay, I'm gonna run this. Okay, so it says for the forward. So for start to end on our forward total, we get 100. Is that accurate?
No, the answer's supposed to
Yes.
be. Oh, I thought you meant the cost.
The forward total should be 100, right?
Yeah, because you go forward one. The B to the second one's wrong.
The backward total
202, 201.
A to B. Yeah, it should still be 1, no?
Wait, what? Oh,
Oh, I'm still checking the first example just to make sure it got the right
oh
numbers.
yeah, that's right. The second one's where the issue is.
Okay. So from B to A. So from B to A, our forward total is we're going from B. So our forward total is 0. And then,
We have to go forward 25 times.
yeah, which is still 0. But we're not including the A, correct?
We shouldn't, but it looks like we did.
Did we say that in our prompt that we should? I think this is really the issue because this is just an edge case issue because if we ever do start -1, that would take us back to something that we don't want to do. So anytime we say start -1, we shouldn't do that. Like remember in our previous example where we like had an if condition for this. So like
Oh, yeah.
if either our start or end, in this case, our start or end is equal to A. Dang, brain fart. All right, because I'm trying to think of so many things at the same time. So let's just think of one thing at a time. So if if our start in this case our end is A, and then we included it. What was it?
We're not supposed to include A.
No, wait. So the forward total is correct for the first one, no? We
Yeah, it
included
is.
the
It
B.
is. It's
No,
just not for the.
no, it's not.
How? Wait, it doesn't
Next
cost
cost
100 to go from A to B? It does cost 100. What's wrong about
from
that?
B to A. No, from B to A. I'm on B to A. I was looking
Oh.
for the forward total for B to A.
Oh, yeah, that's incorrect.
So from
Because it counted B itself. It should be 1. Wait, no, it should be 0, apparently. B to A. Oh, yeah, because it is 0. I was looking at the previous cost. Yeah. It should be 0.
so which if statement do we do for this?
Yo, that's what I'm saying. I'm
One.
just like amazed looking at this shit.
So we would do like our start is not equal to 0, right?
No. Start is
So
definitely not 0.
wait, first is our end greater than our start? Our end is
Yes. B is bigger than A. So we're here.
if our start is equal to 0. Yeah, our start is not equal to 0. Else, I feel like this may not be cover all our cases because we may need to also check for the end. If the end is equal to 0, we're still doing mischief. But let's just go for this, understand what this is. So we're saying else forward total, which is next pre.
You didn't print the. It's gonna be so long though. But yeah, we might have to print. Next pre.
You can print our.
Is there any way to look at this?
You just print it.
So end is B, which is just 1. So the accumulation that would equal 100. That's the problem.
What?
Because right here we did forward total equals next pre of n minus 1. End is B. So we look at the second index in the next cost. Minus 1, that would be 100.
So say that again.
Like, so this is B, right? If we look in our next cost, end is B.
Did you highlight somewhere?
Oh no! So this is like the line where that the second one's at, right?
Okay. Yeah. Okay.
Wait. All right. Never mind. I was looking at A. So A minus 1. That just wrap all the way around, right?
So this.
Because A is N is A is the end.
Yeah, A is the end. So n minus 1, which is
101. No, we're just 100. My bad.
It's just
just 100.
Just 1, right?
100.
Just 100. Okay, yeah. If we're looking at the first one, yeah. Forward total, yes. Forward total, yes.
Then.
Okay.
start -1, which would be b -1, would be 100 as well. How the hell did he get 100? How did he get 200? Oh, no. How did it get cost 101? There isn't even 101 like value inside the next cost
No,
array.
from the previous one.
Oh, from the last one. Okay, yeah. So they got 100. It's supposed to be 0.
I slightly didn't get what it did there, but either way, what do we want it to do? We wanted it to uh, go from B. We wanted it to get the cost of everything from
B
we
forward.
wanted it to get the cost of B minus B minus 1, right?
Yeah,
Minus the full. Wait, full minus B minus 1, right?
I think so.
So basically, it needed to do this, but it did this. So this is our issue there.
Yeah.
All right, so we just need to create an if statement that correctly accounts for all conditions where we need to loop, right?
Yeah. Why doesn't this work?
So,
Because end is
or
okay.
so like because this is a looping, right? This is gonna loop. So this looped because our end is greater than our A.
Yeah. I thought that's why you're supposed to loop, but apparently not.
If our end is greater than our start, our end is greater than start. This says we should. This says this should go like this, no?
Yeah. Wait, what if we just did the start is less than end? Does that mean that we don't loop then? Then if you loop, you do this. Starts less than end, and that means no need to loop. And then you loop here.
Okay, let's see if that works. So from A to B, A is less than end?
Yeah.
So then we do for a total, which is so we're still doing our start is equal to 0. So we don't do this.
What the? Yeah.
Yeah, wait. So we
Our
do
end
this.
is equal to 0.
So
And oh, you're looking at the first one? The first one works. The second one has
yeah,
issues.
so let's okay. So if B is greater than 0,
B is greater than
wait,
A, so that means we need to wrap.
So A, which is B. So our start is B. B is less than A. No. So then we should do this.
Yeah, we should. total. The next prefix of -1, so we have the accumulation. So that should be 101. Oh, no, just 100. Minus the next prefix at start, -1. Start is B. B minus 1 is 100. That's an issue. This shouldn't it just be start plus
Wait,
next
no.
pre at n?
We need another if condition in this f, because this works for some examples. That's not a. For most examples, that's not a, right? If we did the start -1, if you put the -1 back. But if our start is is like a, then we should do a -1. But let's trace this. I was spacing out when you started tracing. So next pre -1 is like
100.
What's, oh yeah, 101, right?
Just 100. Because the accumulation of the whole entire next cost array.
Oh, forward. Oh yeah, we're doing forward. I'm sorry, I was looking at it back. Next. Yeah. So next pre start -1, and what is that?
This would be 100.
Our
That's
start.
wrong.
Our start is a -1.
Wait, maybe it's not. I don't know. Start
A
is
minus
A.
1 is 100. So 100 minus 100 is 0, right?
Actually, that does sound good. Yeah. And then it should be
Plus
plus
next
0.
and
We should.
1.
That's what we want to
The
happen.
thing is, though, our whole next pre array all have 100. There is no way that we could get 100. We could get 1.
Yeah.
Are you looking at the next pre values?
Next pre values. Wait, why are they all 100? Wait, can we did you print both of them?
No. This makes sense actually. We the issue I guess that's not our issue. Our issue is that because we can get one from our previous prefix array, but we can't get 100 from yeah.
We can get one. So you're saying that's right? Forward cost is 100? Wait, no, it shouldn't. It should be 0 because we can go forward.
So should this be a minus? Did we write it? Nope. Okay.
Yeah, I don't.
Okay.
You want to ask the AI god for a hint?
Do you the book? Do you
All right, if you got this, I'm down.
no, do you? I'm here with you.
Because holy shit, this is not going well. This is Jesus Christ. All right. Let's see what we got here. It says we're 80% there. It says it doesn't like our start equals 0. It says prefix sums are designed so you don't need special cases. If you need them, that means your formula isn't uniform yet. What's actually right in your thinking? Building the prefix sums, we got that right. Using the full loop. Yeah, the prefix start thing, yeah. Adding a prefix end. Yeah.
But we accounted for our start in the previous example, no?
That's what I thought. I don't know. AI could be wrong.
Do you want to come back to this problem? Like, can we do a different problem and then come back?
Yeah. I'm out of here. You don't gotta tell me twice. Literally anything but that. Fuck that problem. If they ask me prefix someone to interview, I don't know, jump off a building or something.
Goodness.
Nah. Not that extreme, but I just not right now. Alright, this is a random question. A minimum penalty for a shop. Customer visit log of a shop representative. Characters Y means that the customers come at the 5 hour.
It's like a random median problem. That's what this is.
Yeah. I don't even look at the topics. Don't look at the topics either. Maybe we could figure this out. Indicates that the customers come at the 5th hour. If the shop closes at the Jth hour, the penalty is calculated as follows. But hey, yo, if this is dynamic programming, just like backtracking, it seems like you gotta like calculate a lot of stuff. Customers come in.
Oh, it has been a while since.
It might not be TP. I don't know.
Still trying to understand the problem.
prefix some problem? So you have to, because you have to know how many customers come in at what hours. Prefix some.
Hey, what are you thinking? What are you thinking?
We need to find the index in this customer string that has the least amount of ends, because that will increase our penalty, and the most amount of. Actually, I don't know. Let me think about this more. So we want to close the shop to minimize the amount of hours that are open when no one comes in. But we also want to close the shop too early that people are trying to come in and they can't get in.
So I'm thinking, like, if we're going from increase in order, I feel like we did a problem very similar to this before. But what we do need is like time and close. We can say that's a variable.
Isn't that the answer?
And yeah, and we also need our penalty for that time. We need these two variables, right? And while we iterating through every possibility, we're gonna change this and then change this. So at the end, of course, we're gonna return time to close. So like, let's say we're doing y and y, right? So yeah, we need to know how many y's we have and how many n's we have, which is very easy to get, right?
Yeah.
So our y is equal to 3. I don't know if we necessarily need to know how many n's we need. So, but for now, we'll just skip it. So like, if we start with this first y right here, right? So if we close this, we have n, y, n, y. So we can say that we deduced our new penalty is either penalty we will get 2, and our time we close is 1, right?
Yeah.
Now, if we move forward and we change this to n, and we closed at 2, so our penalty is n, and we closed at. So we need to compare something. We need to compare here. What's our time to close and our minimum penalty?
Yeah.
So min of cur times penalty.
Man, I don't really get the algorithm. Wait, what are you doing with this whole like changing the y's into n's?
Yeah, so I'm just really looking at the example they gave us for the first one. So like if you see like this thing right here, this is really what I'm actually doing, just doing this. So like if you understand, like this is a y, this is a y, this is a n, and then this is a y, right?
Yeah.
So actually, they computed the first one, the whole field three, as the penalty equals,
The number of Ys.
yeah. So in the beginning, our penalty should have been write this better like this. And the time we close is at 1.
I thought it was 0.
Is it 0? No, we
This
can
is
say
the
0.
shop closes at 0th
0 or 1.
hour.
Depend, yeah. Okay. So then we have all y's in the beginning, and then essentially we're just turning off as we go. We're just turning off a y. So first we would have ny, and we have 2 penalties. So the algorithm says if we use that algorithm to take the 2, because the 2 is less than 3, and so our time to close is now 1 if we're taking the 2, right?
Yeah.
So far so good. Yeah. And then we're gonna do a nyn, nn, and y. So now our penalty is 1, and since our penalty decreased or moved over, we're gonna say this is our new time to close. Right? And then we move over to the end. It's already closed, so we do nothing there. Or do we do the opposite?
Opposite.
It looks like we do the opposite. We do the opposite, so we opened it. Why would we ever want to open something?
Wait, what? What are you? What? Do opposite what?
Because initially this is nynn, so we had the third step here. So like the next one would be like nyyyy. So our penalty would be 2 here. But why would we ever want to do suchness?
Wait, that's saying the shop closes at what hour?
We want, huh?
What does this represent? The shop closing at what hour?
3.
0 index was 1, 2. Well, you mean the 4th hour? Or what do you mean?
3. Time to close is 3 if we would do this.
So it closes at this Y. Why are you at the second Y?
We would open here.
Doesn't the first one represent? Isn't it goes by 0 though? So 3 would be the 4th one. There's like
so
a
for
0th
the 3rd
hour.
hour. Yeah.
The 3rd hour would be here.
Is it good?
Yeah.
Okay. So then we would try this, but I don't understand why would we keep it. So we do the opposite. So if we did the opposite of this, then our penalty would then increase to 2. Since we already have a lower penalty, we're not going to change our answer. We're going to keep this as the same as of our penalty. And then we're just going to move on to the next one. If we move the next one over and then say it's n, our penalty would then be 1. Our current penalty is 1 already, so since it's already 1, we do not do anything, and then we keep our time to close to 2, and that's really all it is. And we return the 2. Did that algorithm make sense at all? Or
Are we actually changing the values inside of the customer's string? Like, how are you doing that?
we don't need to do it if we already know the amount of values. This is just for like traceability purposes. But since we already know the amount of y's and n's, we can just
Why
do
does it
this
say 2
mathematically.
if there's 3 y's?
Huh?
Why you have 2? Why say y equals 2 if there's 3 y's?
I think I was tracing in the beginning and I stopped using it, but you can say this is where it starts in the beginning. So I don't think we used any extra data, like super tricky data structure, like uh, uh, like memorization or DFS or BFS. We just used an array and math. Is that the part? Can I look at the topics now? Is that okay?
Oh yeah, go for it. Prefix sum. Who would have thought?
Oh,
Who would
prefix.
have thought? I literally picked this randomly. I did not know it was prefix sum. I thought it was prefix sum when I read it. I was like, this. Who would have thought? My worst nightmare.
I can vaguely see how this is prefix sum. But I think my solution so far works. And then we could also, unless you want to go straight into prefix sum. You want to go straight into prefix sum? Huh? No?
Wait, so how are you doing this? So you do a counter on the y's and n's, and then with that information, you say closing at the 0th hour means that you have a penalty of 3. Closing at the first hour. How do you know? Doesn't it matter what position they're in? Just knowing how many there are.
Yeah, so if we don't use like this logic example, we can follow again. I feel like I may need this for later on, so I'm just gonna probably move it here. So like, if we're just using these two things, we can start off with like 3. So our penalty is gonna equal to 3 because there's 3 n's, and then we'll
3
start back
y's?
at 0 because there's if the penalty is equal to the amount of y's we have. Is that correct? I would say.
Yeah, you said n's. That's why I was like, what? Yeah, y's.
Oh, I said n's.
Yeah, but yeah, y's. Yeah.
So we start off with the 3 y's and then go with the n. We're iterating through the customers, so we have a for loop that iterates through every character in the customers one by one. So let's say like if the character is a, it's a y, we're gonna deduce our 3 to n, and then we're gonna increase our n to n. We see that our penalty is 2, which is bigger than our previous one, so we're gonna say 2, and then we're gonna say our time to close is now 1.
What did changing the
We may need
n do for you?
hmm?
What did
We may need
changing
an
the n
enumerate
do?
formula. Huh?
What did changing the n do? Like, why? What's the point of that?
I don't know if it's necessary, but I'm doing it for now. It may not be necessary
Like, why are you doing it?
because it may come in handy. I don't know. Let's see.
Wait, why do you think it may come in handy?
I don't know.
Wait, what? So there's no like rhyme or reason behind this thing. You're just doing it.
It's an intuition. I feel like we have it here, so why not use it? If it's not necessary, we don't have to code it. But it's for now, it's okay.
So you traced it before. You didn't use
now,
this n. Okay.
Huh?
But it's like, what does it mean though? Like, what does changing the n mean? Like, in the problem.
So that's how much n's we have in the current problem.
So if you close at hour 1, why does n increase?
Because now we have two n's in the full problem.
What was it, hour 1? That means we convert. So what's the formula for that? Like
So
everything.
we're just really subtracting 1 and then adding 1. Subtracting 1, adding 1, depending on what it is.
Okay.
So if our first iteration is a y, we're gonna subtract 1 to make it an n, and then add 1 because now we have an extra n. If it's an n, we're gonna plus 1 because we're gonna make it a y, and then subtract 1.
Oh, okay.
So now we just calculated our first penalty, so we're gonna move on to the next one. We see that it's another y, so we're gonna try to close here, and then increase our thing. And then we see we have a new penalty of just 1. So we're going to
And this
update
is
our new
while
penalty
time
to 1.
closes at 1.
Huh?
Oh, time close. Oh, we're at 2 now.
Yeah.
I just did the y though. So why are we at 2? Why is that the first index?
Time and close is at 2.
If you just looked at the y, which is the first index, and then you set the time close to 2, which is the array is 0 index.
Yeah. But initially, we had a penalty of our 0 is our initial penalty of just the whole thing, just the YYNY. That's considered as our 0.
So time close is going to be ni plus 1.
Yeah. Okay. So we see. So are we good? Can we move forward?
I mean, sure. I was asking why it was the index thing, but you said just add 1, so that works, I guess.
Yeah. And so we see that the next one is an n. So we're gonna increase our 2 and then decrease our 3 to n. We see that the penalty now is higher. The penalty now is higher. So we're not gonna do this. Yeah, I don't think we need the n because we haven't used it and we're not gonna use it anymore. So let's just say our penalty is our current penalty is 2. It's not less than our existing penalty, so we're gonna keep our 1 and our 2. Then we see the next value is a 1. We see it's a 1. While the penalty and our current
The next
penalty
value is
is
a
equal to
1.
the same. Huh?
Oh, you mean it's a y? Oh, it equals a y. Okay.
Yeah. Since they're the same, we're just gonna keep the same thing because the problem says to keep the one that occurs the earliest. So it's 2. And then we've reached the end of customer, so that's really it.
Still it.
What do you think? I think that's good.
Yeah, I mean,
We do
it
it.
makes sense, yeah.
So we need a
What's confusing
penalty.
me is like the idea of closing at a 0 hour and the idea of closing at a 4th hour when there's not 4 hours in total.
Yeah. Hopefully it'll make sense eventually.
No, I'm not saying it doesn't make sense.
So
I'm saying this is why it's confusing to me.
fine. Close. So our penalty is equal to actually counter of what are we getting? Customers. Right of values. So we only want the y's, right? Yeah. So maybe I can't do this in one line. I feel like I could, but it's not important. So I'll just do it in 2 lines. So then our initial penalty is equal to 3, right? And then our time to close is 0.
And right, like, don't you just do like for I and no for S in what's it called? Customers?
Yeah, but the thing is, we need to use enumerate.
Wait, why?
Because to update our time, we need, like you said, n plus 1, I plus 1. Where we currently at, plus 1.
So we don't really need. I mean, we could use enumerate, but we also could just use for an I, right?
Yeah, but it's much cleaner if we use enumerate, I think.
Oh, customer. Cus I in.
I think it's index value.
Oh, it's index first. I just kind of want to try this. I was so confused when you were explaining it. I think it's starting to make sense. I'm pretty sure, like, if cus equals y, if cus equals y, that means we closed on y. So that means our penalty will go. So go minus equal 1, right? Because we closed on someone that is trying to come in. Else, well, there's no else because penalty just stays the same, right? That means
No,
we
we need
closed.
to increase our penalty.
Wait, increase it?
Yeah, because if it was an n, that means we opened, and then would increase the penalty.
Oh, I thought this was saying that we're closing at index I. That means we're open.
If it's y, we're closing, which is why our penalty decreases. But if it's an n, we're opening.
Wait, nah. I'm back to being confused. If it's an N, we're open. How can we change it for opening or closing?
So like if you take a look at the 3rd hour of the example,
Yeah.
you see how it's we have an n there, and it changed from a 0 to a 1.
Change from a 0 to a 1. Yeah.
So it said that because we were closed before, and then we opened. That means we have a new penalty.
Oh. If it's an N, our penalty plus equals 1 because Yeah, okay. So if it's a Y, that means we're open and we help the customer. So our penalty goes down. If it's an N, that means we closed and our penalty goes up. And wait, what do you do now?
We need to update our time.
What are we comparing it to? Don't we have to like?
So we're comparing it to what our current and previous penalty was, and also, yeah, what our current and previous penalty is.
So how do we? What do we write? Like what?
So I'm thinking what I'm thinking here is like, should we even care? Like, if it's an N, we know our penalty increases, and so there's no chances that we would update our time to close if our penalty increases.
Yeah.
So, so if it's a Y, I'm thinking we do it in here. So like we're gonna say if um, we need a master penalty. Like, what's the lowest penalty that we've had before?
It's min with capital M. That's usually do. Oh, he's naming stuff good. He's trying to impress the interviewer.
uh, this would also equal to
Penalty in the
characters
beginning.
Y in the beginning.
Oh, yeah.
Yeah.
If penalty less than min penalty, time equals I plus 1.
Mm. So I don't think it matters if we do it in there or not, because it will never. This, if we increase the penalty, this will never run. So and I think we just return penalty, return time, which should be a lowercase.
It works.
Nice.
Nice. I was thinking of something here. The thing that confuses me that I just like this whole closing at a time that doesn't exist. Like, what the hell is an hour zero? It means you closed before a store even opened. That's like
Basically.
crazy. And closing at hour 4 when there's only 3 hours. You closed after the store closed. I don't know. Is there a way I want to write this? I was like, because if you think about this, the penalty. So the penalty is going to be The penalty at the 0th hour is just going to be the count of y, right? So can't we just do for I in range length of customers and start at 1 because this represents 0 already? And I don't know if we have to go to +1. I think maybe +1 because
This doesn't represent 0.
yeah,
This
the
starts
number of
this.
y's.
Yeah.
The number of y's is the penalty if you close at hour 0.
Yes. Yes. That's
So that
correct.
that represents 0. So if you it's like we don't have to do +1 anymore because that +1 stuff is like
That
I don't
represents
know.
times 0 is what you're saying?
Yeah, the 0th hour. Yes, yeah. The
Okay.
penalty at the 0th hour is this the default penalty when we initiate it.
Okay, that makes sense. Yeah.
So if we were to start at 1, I mean, how does this change? I know it's the same problem, same answer, but it's just like thought about differently. So if we start at 1, we would look at the n and we'd say, hey, if we were to close at hour 1 instead of 0, that means what? That we would. No, it wouldn't even work because once you go out of bounds, what happens? I think your answer might have been better.
Wouldn't you also miss the first index?
Isn't index
You
0?
have
That's
to
like
change it. No.
when you say first index, you mean like index 1 or index 0?
Yeah. No, index 0.
This is index 0. The time is 0.
This doesn't represent index 0. This just represents how you found your store, basically.
But let's say the penalty, that's the best penalty when we return time at the end, it's just going to be 0. Because like in example, hour 0, which is time 0, equals 3, which is 3 here.
Mm-hmm.
So this is already calculating what would happen if we close at time 0.
Yes.
So I'm saying like, so since that's already calculated, can't we just start at 1?
I think it's not calculated. It's not. I think.
Explain how it's not.
Time 0 is not like an index. Time 0 is like a figurative full house. It's like a full house. It's not like closing. Like we haven't technically opened to close, if that makes sense.
So if I did this at 0, I don't think anything would change. It would still be 3.
No, it wouldn't. It would be 2.
Yeah, I think I hate this problem. I think, yeah.
Okay, all right.
I don't think it's like a problem thing. I think it's just that I didn't take a break when you left. I think I'm just done with Leetcode right now. I'm gonna come back to this.
Fair
It's
enough.
really not that hard to understand. This is like 3 lines of code or something. I'd all right, yeah. I think I'm logging off. I'm gonna go outside and go like get some fresh air.
Sounds like a great idea.
Yeah.
I gotta be like you. I gotta find the energy to run.
I mean,
And I
I
do
feel
like
like
energy.
it was better when it was warm. This is kind of like the hardest time to go running.
Today's good weather though. It's like 49 degrees or something.
Oh, it is. Yeah. Damn. Yeah, my
How do you
brain's
get your
fried.
shoes, stop your shoes from like getting wet?
You don't. I don't. You just gotta deal with it, or like I don't know, jump over puzzles or something.
Mm.
Damn. Yeah, I'm definitely coming
Alright,
back to this.
alright.
This question's not even hard. I'm just like, nothing makes sense anymore. It's like after like 4 hours of
Yeah.
Leetcode, your brain just starts hurting.
Totally get it. Sure.
You're getting on
Thank you for
tomorrow.
rejoining, because
Yo, all we did was get stuck at that fucking problem. The prefix something.
oh yeah, that thing is super wild.
I gotta come back to that and fucking solve this again.
Sounds
All
like
right.
fun, yeah.
I don't even know if I want to
Alright,
try
guys.
that again. I mean, I do, but I don't. I feel like it's important, but I
In a very
it's
fresh brain, like I feel like we gotta be super ready to do next. And it's like it has to be like the first thing we tackled if we do it.
yeah, cause
It takes a lot of thinking. That's a
yeah,
lot of willpower.
definitely. And yeah, so I bet. So I'm gonna be out tomorrow. All right,
All right.
peace, man.